Okay, now we're ready for part 2 of 1.6. So here, we're going to start with solving an inequality in the form absolute value of x minus a is less than or equal to b for the real numbers here that a and b, where b has to be greater than 0, okay? So we're going to have three methods rather. And so the first method says we can use it for absolute value of x minus a less than or equal to b, or absolute value of x minus a greater than or equal to b. So this is kind of you can use this for no matter what you want to do. Now method 2 says we can only do it for absolute value less than or equal to b, and method 3 is strictly greater than or equal to b. So these are specific to inequality symbol. The first one you can do for either symbol, and it doesn't matter. Okay. Now we'll work these problems with multiple ways, and then eventually we'll say, okay, which way was the easiest, and we'll start doing it that way. So the first one, method 1, we're going to find the boundary points by solving the absolute value of x minus a equals b. And we know how to solve that. We just did that. You're going to set x minus a equal to b and x minus a equal to a negative b. And so when we do that, that's going to give us 2 points. And when we solve it, we'll get x equals something and x equals something else. And we're going to call those a and b here. And it's not these same a and b's, but it's similar. And what it's going to do is it's going to give us test intervals where we have these points here. And so we can choose any point in this region, any point in this region, and any point in this region, and we're going to test those to determine where the absolute value of x minus a is less than or equal to b, or if we're doing the greater than or equal to, where it's greater than or equal to b, okay? And then when we find the ones that's true, because some of them might be true here and here, some of them might only be true here, and so you have to kind of test them all to see where it's at. Then we're going to write the interval or union of the intervals satisfying the inequality. So it might be, from negative infinity to a, and then from b to positive infinity. Okay, so that's kind of how it's going to work. Now method 2 only works with less than or equal to. And so what we're going to do is we're going to rewrite this expression and solve. And so we're going to rewrite this as x minus a in the middle, and is less than or equal to b here. But then we're going to say, well, that's greater than or equal to a negative b here. So we're kind of putting on this left side here. This is going to be the part that we're adding to solve the less than or equal to. And then we solve for x in the middle, and so we're adding a to both sides. And then whatever that solution is, that's the interval that's going to work. And then you just write it in interval notation. And so it's just going to go from bracket whatever negative b divided plus a is, and then on the right side it's going to go up to the b plus a, and then another bracket. That will be your interval notation. Now method 3 is for the strictly greater than or equal to here. And what we do is we rewrite this, and somehow my x got large here, but we're going to rewrite that as x minus a greater than or equal to b, so we just keep that, or x minus a is less than or equal to b. Now we solve those, and the solutions to both of these are going to be the intervals that work, okay? And so it's going to be, this area here and this area here, whereas the less than or equal to b, that's going to be this middle area here. So again, we're going to do it all 3 ways depending on the problem, and that way you can kind of determine which way you like the best. So our first one here, we're going to solve, and we're going to write in interval notation. We have a greater than or equal to, and it says use method 1 first. Well, in any of the methods, what we have to do is we have to isolate our absolute value. So let's do that first. So we have 2 times absolute value of v minus 7 minus 4 greater than or equal to 42. So that means I have to add 4. And so 2 times absolute value v minus 7 is greater than or equal to, now that's going to be 46. Now divide by 2, and so we get absolute value of v minus 7 is greater than or equal to 23. All right, so method 1 said we set this, we just drop the inequality and we set it equal to. And so we're going to say, well, v minus 7 equals 23, or v minus 7 equals negative 23, okay? And this is with method 1. And so now we solve. And so we add 7 to both sides here. And so v equals 30. And here we also add 7 to both sides. and here v equals negative 16. So these are 2 points. And so on our number line, what we're going to do is we'll say that's 30, that's negative 16. Doesn't have to be drawn to scale. What we want to do is we want to test some point over here. We need to test some point in the middle here, and we need to test some point over here. Okay. Again, it doesn't matter as long as that point is in the region. So let's test maybe negative 17. Now between these two, the easiest one to test would be probably 0. And on this one, I don't know, let's do something. Here we went by 1, so let's go by 2 here. I don't know. So here we have to plug in negative 17 into our original equation up here and see if we get a true statement. All right. All right, so when we do that, and we could technically work all the way down to get to this point here and do the same thing because we're going to be doing all those things. So maybe it might be easier just to test it into that equation right there. So when we do that, we have absolute value of negative 17. Oops, we don't need another absolute value here. And then minus 7 and greater than or equal to 23. Now this is assuming we've all done all this work here. Otherwise, you really should go back to your original, but kind of to show you that it works here, we can do it here. So then we have absolute value of negative 24 is greater than or equal to 23. Well, the absolute value of a negative 24 is 24. And so we have that, and that's a true statement, okay? Now, let's see here. What do we got for the other one? So that's true, so that one works. Now, if we plug in 0, we have 0 minus 7 greater than or equal to 23. Well, then we have absolute value of negative 7 greater than or equal to 23. Well, absolute value of negative 7 is 7. Well, that's false, so that one doesn't work. And so then we can plug it into the 32 there. So we can say, okay, well, 32 minus 7 is greater than or equal to 23. And so here we take 32 minus 27, was that 25? And so that's greater than or equal to 23. Well, that's true. And so that's true here. And so our notation is going to be from negative infinity to negative 16. And then we're going to have a bracket because we have the greater than or equal to. And then union, it's true over here too. So it starts at 30, so that's a bracket. And it's going on up to positive infinity. Okay. Now again, we could have plugged it back in here and that would have been probably the more technically correct way, but we've already done all the math here, and so we didn't have to. But if we did it the original way, let's test one of them. We can do the negative 17. It doesn't matter. Negative 17 minus 7 minus 4 greater than or equal to 42. And so then here we have 2 times absolute value of negative 24 minus 4 greater than or equal to 42. And absolute value of 24 is 24, so we have 2 times 24, and then minus 4 greater than or equal to 42. So 48 minus 4, wait, is that 48? 48 minus 4, yeah, okay. Greater than or equal to 42, and then 44 greater than or equal to 42, that's true as well. And so it works that way, and it also works this way. So if you're very confident, you can go the way I did it here, and if you want to do it this way, it's the long way, it's probably the technically more correct way. You also get the same thing. So that was method 1. Now method 2, our method 3. Now we have to make sure we're getting the right method, because here we're doing the greater than or equal to, so that means we have to do method 3, sorry. And so method 3 says, well, what we have to do is, again, solve down and get this so we have absolute value is greater than or equal to something. Well, we did that already. We did all that work, right? Here, and we got to the v minus 7 greater than or equal to 23. So let's just use that, and then that saves us a little work. So why reinvent the wheel? Greater than or equal to 23, okay? Now with method 3, what it says is we're going to drop the absolute value and say v minus 7 is greater than or equal to 23, and then we're going to say or v minus 7 is less than or equal to a negative 23. Okay, well then we say, well, let's add 7 to both sides. And so v is greater than or equal to 30. So that's the first part. And remember, when we get this, this is going to be the actual intervals that we have. And so here we're going to add 7. And so v is less than or equal to negative 16. Well, this, if you look on a number line, what it shows is kind of what we found before. So 30, negative 16, and then it's going to be v less than or equal to 16. So we're going to have solid circle, and it's everything going that way. And here v greater than or equal to 30. It's going to be everything that way. And so we're going to have the same interval, negative infinity to negative 16, bracket union, and then we're going to have bracket 30 to positive infinity. Okay, and that's what we found on the last one. We just had a little bit more legwork to do along the way. I mean, we initially did this here part to get to this, but that's pretty easy, and then the rest of it, again, it just follows through and we get our answer. All right, so here we have one. Now this time we have less than or equal to, and that's because I want to show method 2 as well along the way. All right, so we have 3/4 x minus 5 plus 1 less than or equal to 16. Well, I need to subtract 1 to isolate that absolute value. And when you subtract that, that's going to be 15. Okay. And so now what are we going to do? Now we're going to drop our absolute value, and we're going to set equal to instead of the way we're doing it with inequalities. So we're going to have 3/4 x minus 5 equals 15. And then we're also going to have 3/4 x minus 5 equals negative 15. Okay, and this is to get our 2 points where we can then get our test regions after we get these 2 points. So when we do this, we add 5. So 3/4 x equals 20. Now I'm going to multiply by 4 over 3. I'm going to multiply by 4 over 3. And so x equals 80 over 3. Okay. Now what about the second one here? Well, I'm going to add 5. So I have 3/4 x equals, here I get negative 10. Again, I'm going to multiply by 4 over 3. And so when I do that, I get x equals a negative 40 over 3. So my regions is negative 40 over 3. And then here we have 80 over 3. Now, what kind of numbers do I want to use here? Probably first off, you should divide 40 by 3 to kind of give you an idea where that is. So that's going to be negative 13 1/3. And this is going to be 80. It's going to be divided by 3. That's going to be 26 2/3, I think. All right, so what I need to do is something in this region over here, something in the region here, and something in the region out here. So since this is negative 13, I don't know, maybe let's do negative 16, okay? And so here, guess what? I'm going to choose 0 because it's in the middle. And over here, I don't know, if I'm thinking about the problem, I want to divide it evenly by 4, and so I'll probably choose 36 maybe. And I divided this one by 4 to get the even number here too, because I knew I'm going to have to divide by 4. So now I test. Now, again, we should probably test back in our original, so let's go ahead and do that this time. So 3/4 times now a negative 16, and then minus 5, and then plus 1 less than or equal to 16. And so here 4 goes in here, and we have a negative 4. We have 3 times a negative 4 is going to be negative 12 minus 5 plus 1 less than or equal to 16. So that's an absolute value of negative 17 plus 1 less than or equal to 16. Well, that's 17 after you take the absolute value plus 1 the less than or equal to 16. And here that's going to be false because 18, oops. Too low here. and that's supposed to be less than or equal to, but I can't get it on the bottom, and 16, and that's false. Okay, so that one doesn't work. What about the next one, 0? Well, okay, so now we'll take 3/4 times 0 minus 5 plus 1 less than or equal to 16. Well, that's 0. And then so I have absolute value of a negative 5 plus 1 less than or equal to 16. Absolute value of negative 5 is 5. And so 6 less than or equal to 16, well, that's true. And if you remember, it's usually with the less than or equal to, it's that middle term here. And so that should be the one that works. Now, not always. You have to always test all three regions. And so now we take and do 3/4 times 36, and then minus 5, and then plus 1, and less than or equal to 16. So 4 goes in here, 9. They have 27 minus 5 plus 1 less than or equal to 16. Well, that's absolute value of 22 plus 1 less than or equal to 16. 22 plus 1 less than or equal to 16. And so 23 less than or equal to 16 is false. And that's what we kind of suspected would be the case. And so what is our region that's true? Well, our region is negative 40 over 3, comma, 80 over 3. Okay, and so that would be what our final answer is for method 1. And again, you have to do all this work to do all the tests to make sure each region is working and in the proper order. Now we're going to do method 2 because it's less than or equal to. So let's go back and remember method 2 says, well, we're just going to rewrite it as changing this and adding that to the end, dropping absolute values, and that's all we have to do. Okay, so method 2. All right. So what do we have to do? Well, if we remember, we have to isolate this absolute value here. So we already did that. We subtracted 1 and we got 15 here. So that was 3/4 x minus 5 less than or equal to 15. And that's where we were at the point where we isolated the absolute value. And so now let's drop the absolute value. And so we have 3/4 x minus 5 less than or equal to 15, but it's going to be greater than or equal to a negative 15. Okay, so now we're going to do the tripartite, and so we have to add 5 to all three parts. Okay, so then minus 15 plus that's going to be minus 10 less than or equal to, now we just have 3/4 x less than or equal to, here we have 20. Now how do I get rid of this? Well, I have to multiply by 4/3, and so I have to do that on all three parts again. And so 4/3 times that, that's going to give me a negative 40 over 3 less than or equal to x less than or equal to 80 over 3. And this automatically gives me my interval we just found, negative 40 over 3 and 80 over 3. Again, method 2 seems a lot easier, kind of like method 3 did, and that's the one probably what I will use most of the time. Method 1 is good to know because you have to be able to know how to test your intervals on other things later, so knowing how to do that is going to be kind of a key. So all three methods really should be known here. All right, so this one, it just says solve. It doesn't tell us how. So let's think about it. Okay, so we got greater than or equal to. So if we remember, let's go back. Greater than or equal to, we can do method 1, or we can do method 3. Now let's do method 3 because it seemed to be a lot easier than finding the 3 test points, plugging in numbers for all 3, and doing all that. So let's go ahead and just start with doing that method and not even worrying about, what is good, what is bad. We're just going to try that method to start with. So we need to add 4 to both sides. So that gives us 3 times absolute value of x plus 1 greater than or equal to 9. Oops, in absolute value. Now we divide by 3. So the absolute value of x plus 1 is greater than or equal to, well, that's just 3. And so we're going to do method 3. Now, if you find method 1 is easier because you can follow through with it, go ahead and use that. It's not a bad deal. Sometimes they'll ask you to do this method versus that method. But when they don't tell you what method to do, then use the one that you think is the easiest for you to do. And if you always think method 1's better because you can do it on either way, go for it that way. All right, so now what we have to do is we're going to drop the absolute value signs, and we're going to set it greater than or equal to 3, and we're going to set it less than or equal to a -3. And so we'll have x plus 1 greater than or equal to 3, or x plus 1 less than or equal to a -3. Now we just solve. -1, -1, and -1, -1. And so if we draw the number line to kind of make sure we have it right, because I know I've seen a lot of students see these, write it wrong, and so then you get it wrong and they don't know why. They got up to this point correct, but then when they wrote the interval notation, they have it wrong. So let's make sure we know how to do that. So this says x is greater than or equal to 2. Well, that means we're going to have a closed circle, everything to the right. This says x is less than or equal to -4, so it's going to be a closed circle and everything to the left. And remember, we write our interval notation from left to right, so we start over here. Well, that's that -infinity up to -4, bracket, union. Now we move over here, and then we have bracket 2 to positive infinity. Okay, so I think doing the number line is ideal. That way you really see what's on the left side, what's on the right side, and you write it from the least number to the greatest number, okay? And not splitting them around, moving them around, because then you're going to get things wrong. All right, what about this one? Well, this one, I see I have less than or equal to, so I'm going to probably use method 2. And when I do that, I have to go ahead and solve for the absolute value on the left side. So I'm going to add 7. And so 5, absolute value of x minus 4, less than or equal to 789. And then divide by 5. So absolute value of x minus 4 is less than or equal to 9/5. Okay. So we have fractions, but you know we can do fractions. And so when we have less than or equal to, remember what we're going to do is we're going to drop that, and this is going to be method 2 that I'm doing. We're going to have just the absolute value dropped in the middle. That's going to be less than or equal to a 9/5. And then we're going to put greater than or equal to, and we're going to put a -9/5. Okay. Now what do we do? Well, now we add 4 to all 3 parts of the tripartite. But when you do that, we have to multiply by 5/5 and multiply that by 5/5 to get the common denominator of 5 here. So here we have 20 minus 9, and so that's going to give us 11/5 less than or equal to x less than or equal to, here we have 20 plus 9, so it's going to give us 29/5. And again, directly gives us our interval where it works. So it's going to go from bracket 11/5, comma, to 29/5, bracket, okay? And that would be our solution. And that's where we can stop at that point right there. All right, so that's the end of part 2.